So this is the last part of section 9.3, and you notice what's on the screen, that we're going to find complex roots. You will have watched a video, and he's going to go through this information, but he's going to go through it using polar form. In our book, it now has exponential form. Like I've said the whole way through this section, you've got to know them all. You have to know how to go back and forth between complex and rectangular and polar and exponential. So here we are. There is a theorem. I do remind you that somewhere on your formula card, I hope you have started and have a really nice complex area. The last thing you need to add to your complex area on the formula card would be the formula for complex roots. You may want to put the formula that he has on the video on there also. I'm going to point out and work through how we would get and we'll use this formula. So it says z sub k, but then also notice we're going to do our k thing again. Notice right here, 2k pi. We're going to have to run this for when k is 0, not any negatives, but when k is 1, k is 2, and actually all the way to the n minus 1. So if we're going to cube roots, cube is a 3, 3 minus 1, we would stop at 3 minus 1, or 2. We would run k for 0, k for 1, and k for 2, and we would be done. Make sure you write this down. A couple of things to point out. The magnitude or modulus, we're going to take the nth root. Like if we're going to cube, it'll be the cube root. If we're going to the square root, it's going to be the square root. You still have the e, you still have the I, and then we've got a little bit different going on here. Parentheses 1 over the n. So if it was a square root, it would be 1 over 2. If it was cube root, 1 over 3. If it was fourth root, 1 over 4. And then here we'll have our theta, plus, and then we got to catch all of the, and by the way, it did say, and I didn't point this out on another video, that here is a theorem that the argument is periodic. That brings in our 2k pi, and we'll use it here for finding complex roots. So there is an example, and by the way, at the top of page 606, this is really cool to read. Not going to take time. We are going to go on to example 7. So at example 7, it says it wants us to find the cube. So 3. 3 is the magic number. And then the form it gives us is rectangular, x and y. They want us to do our final answers in exponential form. Oh, well that's it. Not rectangular and not polar, so just exponential. Deal. Cube, xy, and we're going to have to go where k is all the way to the 3 minus 1. When we get done, we're going to have to do k for 0, k for 1, k for 2. But before we get going on these, we have to get us a template. So that's what we're about to do, is get our template. And so let us jot down this piece over here, that z sub k, in our case it's going to be 3, is going to be the nth root of r times e to the I, 1 divided by whatever n we have. We have 3 in our example, and then theta plus 2k pi. That's going to get us our template when we fill in the rest of the pieces. So back to example 7, which is on page 606. And so looking at page 606, I get all excited and I come right here and my, oops, you can't see that. And my z is negative 1 square root of 3i. This is the last problem I'll be doing with you, so I want to reiterate. I like to look at the graph first thing. I like a drawing, I like a visual of what's going on. If this is my x and this is my y, I'm at negative 1 square root of 3. So at negative 1 square root of 3, not a direction, negative 1 square root of 3, here's what we're talking about. And so it's asking for this complex number, what will be its cube roots? And we're going to have 3 of them, because we're going to let k equal 0, k equal 1, and k equal 2, which is 3 minus 1. So at this point, we need to start filling in our pieces and parts. But we have our theta. It's in polar form, and we're currently in rectangular. So one more time, we get to think about our magnitude or modulus as being the square root of the x squared plus the y squared. And we get our 1 plus our 3, square root of 4. Oh, this is nice. We get a modulus of 2. Looking where we are at our -1 square root of 3, that's going to be very helpful that our theta is the inverse tangent of our y over our x. With that being the case, this is a 60-degree angle. With it being a 60-degree angle, we are at 2 pi over 3. Well, we're done. So we now have our r and we have our theta. So it's now time to start plugging in pieces and parts. We're going to find the cube root of our complex number. We're going to find the cube root, or the 3 roots. We're going to find, which means that number times itself, 3 of those times itselflesses. That's real mathematical. That's going to get us the number that we're looking for, and it'll be the 3 of them. And there's a lot more detail to that, and I digress. I need to get right back up here. Third root of our r is 2 times e to the I, and we have 1 over 3. Then we have our theta, which is 2 pi over 3 plus 2k pi. And we now have, and I shouldn't have written this way, our z sub k. This is our template. Now we're going to go find z sub 1, actually z sub 0, sorry y'all, then z sub 1, and z sub 2. This is our template, and so we're going to take our 0, plug it in for k, and all of that's going to disappear. So we get as our first root, we get the cube root of 2 times e to the I. We can go ahead and multiply these together, and we get 2 pi over 9. Here is one of our roots. I'll go ahead and pause and go ahead and point out to you, where are we? Uh-oh, y'all can't see that. Looking in our book, z sub 0, we get the cube root of 3. We had the cube root of 3. And then we had e to the I times 2 pi over 9. E to the I times 2 pi over 9. I'm going to go ahead and start pointing out the graph. There's a graph at the very bottom. Our modulus is the cube root of 3, and our theta is 2 pi over 9. Notice here we are at 2 pi over 9, and we've gone out our cube root of 3. So here is one of our roots. We have 2 more. To find the other 2, I want to just leave it for you to do, but you can go ahead and hit pause right now and go ahead and calculate it by yourself. That would be a really good idea, because the cube root of 2 is going to stay the same, times e to the I, and here we go up here. I'm putting in a 1, so that means I've got a 2 pi over 3 plus 2 times 1, that's 2 pi. So 2 pi over 3 plus, that's like saying 6 pi over 3, because 6 divided by 3 is 2, and I've got 8 pi over 3. 8 pi, oops, yep, 8 pi over 3. But back in our formula, it's what we get in here times a third, times 1/3. And with that being said, we got 8 pi over 9, and we're going to go ahead and go there and just double check. We think a second root is the cube root of 3 times e to the I times 8 pi over 9. Modulus theta. Looking at our graph one more time. Looking over here at about 8/9 pi, our modulus still being cube root of 2. We found one answer. We found a second answer. But wait, there's one more. Again, this would be a great place for you to pause and work on this next one by yourself. We are now at z sub 2, and that's the last one, because 3 minus 1 is where we stop. So here we are at z sub 2. I've got my cube root of 2 times e to the I times, and pause. It's going to be a third times this stuff in here. I'm going to go ahead and write up here since we're almost done. I've got 2 pi over 3 plus 2 times 2 is 4 pi. So I've got 2 pi over 3, and let's see, 4 pi, that should be 12 pi over 3, because 12 divided by 3 is still 4, and I've got me 14 pi over 3. But all of this is times a third. So I've got 14 pi over 9, or right here, cube root of 2 times e to the I times 14 pi over 9. And we'll go one last time to our graph. And our graph going on around about just over 1 1/2 pi's. And that gets us around here with still the modulus of the cube root of 2. We can see our 3 answers. We can see our 3 answers. And I'm going to stop on example 7 there. If the problem did ask for you to leave your answer in polar form, you could do it on any of these, because on all 3 of these you have the r and you have the theta. The last thing I want to point out is at the top of 607, I would love for you to read all of this historical feature. I love it. And when you get through reading it, you might try A. Don't worry about B, but try A, and here's a little hint. They're talking about using Pythagorean theorem, or excuse me, quadratic formula. And looking at quadratic formula, it's the x equals negative b plus or minus square root b squared minus 4ac all over 2a. And if you let your a be 1, your b be this, distribute the negative, and your c be all of this in the back, it's pretty cool to go ahead and work through using the quadratic formula, and then when you get to the end, you know how it's got the plus or minus? Do one answer to get the plus, and do another answer to get the minus. And I've got a smiley face because I really think that's cool to work out. This finishes all of our information on section 9.3.